Hi everyone. In this tutorial I'll show you how to use the PointDetector node with a custom topology. In case you're unfamiliar with this tool, I highly recommend that you first watch the Getting Started with PointDetector tutorial. Remember that by default the PointDetector node is configured to work with the standard topology that comes with Wrap Gallery. But you can also configure this node to work with your custom topology. Please note that you will not only need a base mesh with a neutral expression, but also a small set of other facial expressions. This set of blend shapes is needed to show the algorithm how a face can be deformed. If you only have a neutral mesh without a set of blend shapes, I highly recommend you to watch the tutorial how to convert blend shapes into a different topology. For the custom topology, we're going to use the mesh we purchased from 3D Scan Store. This mesh comes with a set of 28 facial expressions in the same topology, which is just what we need. Let's load these expressions by dragging the set of files into the graph window. Please pay attention that meshes from 3D Scan Store are stored in meter scale, while Wrap is optimized for centimeter scale. Let's increase the scale to 100. This set contains major facial expressions, including a neutral expression. Next, we need to take this topology and wrap it onto the target character. For the target scans in this tutorial, we're going to use Alex's scans that come with the Wrap Gallery. I've already wrapped Alex's neutral scan with our custom topology, and now I'm just going to drag it into our project. Let's call this node Wrapped Neutral. Let's call this node Reference Blend Shapes. Additionally, we will need Alex's neutral texture projected from the scan. Let me hide the wireframe on our mesh. Now let's load one of Alex's target expressions, which we can take from the gallery. I'm going to call this node Target Expression. We need to wrap the neutral model to the target expression. In practice, we will have not just one, but dozens of such expressions. For each expression, we need to specify correspondences for more than 170 markers on the actor's face. The PointDetector node makes this work much easier. It takes markers from the neutral model and automatically finds the same markers on the target expression. Well, first, let's create a PointDetector node. Let's see how we can configure this node to work with a custom mesh. As the first input, I'm going to plug in the neutral mesh. The second input is going to be our target expression. The third input is a set of points that we need to select on my neutral base mesh. To do that, let's create a Select Points node. Let's plug in the neutral mesh as an input and go to the visual editor. I highly recommend calling every set of points by a distinctive name. It will help us during the further steps. Let's change the base name to iCycle_. Next, one by one, let's select a set of points around the eyes. Alright, for the sake of time, let me select the rest of the markers and come back to you when it's ready. Okay. We've selected all the markers. It took a while, but fortunately you only need to do this step once. These points will be reused later on for dozens of target expressions. Now we can plug the selected points into the third input of the PointDetector node. If we hold the mouse over this error icon next to the node, we can see the message Neutral Geometry and Neutral Blend Shape have different vertex count. This happens because by default, the node is configured to work with a standard topology, while we are using a custom topology. Fortunately, this can be easily changed. Most of the parameters that we need to change are located in the Deformer Data Paths tab. As the neutral reference parameter, we need to specify the path to the file with the neutral reference blend shape of the character from 3D Scan Store. Let's select this file from the disk. As the blend shape references parameter, let's select all available expressions except for the neutral one, which we have already selected. Now we need to specify the path to the file with 3 polygons. As 3 polygons, we need to select the polygons inside the mouth socket. As we don't have such file, let's create it. Let's find a reference blend shape with an open mouth. Now let's create a Select Polygons node. I'm going to switch to the Visual Editor. First, I select one of the polygons on the border of the mouth socket. Then I press Shift and double-click on an adjacent polygon to select the whole cycle. Now let's click Hide Selected to hide the selected set of polygons. We can now double-click on the socket to select all polygons within the socket. Alright, now we can make all polygons visible again by clicking Unhide All. Let's save this selection to a file. I'm going to call this file freepolygons.txt. Don't forget to click on the Save button to write this file to disk. Now let's go back to the PointDetector node and specify the path to the file we've just created. As you can see, the mouth socket polygons are now displayed in green. All that's left to do is to specify the last path to the file for the alignment points parameter. The thing is, our reference blend shapes may have a different scale, position and rotation than our neutral model. Alignment points are a set of points that are used to align the reference blend shapes to our current model. We don't have such a file, so let's create one. To do this, I create a Select Points node. For convenience, I suggest switching to a frame with a neutral facial expression. As alignment points, you can select points at the corner of the eyes, the corner of the lips, and the ears. Now we can save these points to a file by clicking on the Export button. I'm going to call this file alignmentpoints.txt. Now let's go back to the PointDetector node and specify the path to the file we've just created. You may be wondering why we are saving these files instead of plugging in the node's results directly to PointDetector. The point is that we need to configure these file paths only once, so that we can reuse them later on to process dozens of models in the same topology. We just need to click on the Save as Default button so that each time a PointDetector node is created, these paths are automatically substituted. Let's remove these 3 nodes as we won't need them anymore. Good. There is one setting left. Let's go to the Deformer Parameters tab. These settings determine how our model is split into patches. If we enable the Show Patches option, we will see that now our model consists of exactly one patch. Let's set the patches parameter to Generate by Sampling. Now we need to change the value of the sample radius parameter. Since our reference blend shapes are in meter scale, the default value of the parameter doesn't work for us. It needs to be scaled down 100 times to match the meter scale. I would also increase the value of the patch blur weight parameter. This will slightly increase the computation time, but will improve the result. Let's set this parameter to 0.5. Now everything is ready to use the PointDetector node. Let's click on the Compute button. As you can see, most of the points were detected automatically. For the rest of the markers, we can fix the positions manually. First, let's turn on the Show Point Cycles option to better see which point goes where. Next, I manually move the points to where they should be. To fix the points that are stuck together, we can hold the spacebar, grab the point, then release the spacebar and move it to the desired position. Perfect, in just a few seconds we've selected about 170 points. Let's see how much effort it takes to mark the points on the new expression. I'm going to upload a scan with a more complex facial expression from the gallery. Let's plug a new scan into the PointDetector node. First, we need to click on the Reset button to reset the result of the previous computation. Now let's click Compute. This time, significantly fewer points were detected. Let's help the algorithm and put some of them in place manually. I click Compute again. Now the algorithm will use the points we've pinned to improve the result. The rest of the points we can fix manually. Done. To apply the result, let's click on the Accept button. That's it for this tutorial. We've learned how to configure the PointDetector node to work with your custom topology. For each topology, you will need to spend some time configuring, but then you can use this node to process dozens of facial expressions for all the characters with the same topology. Thank you, and see you in the next video.